So I did a video about trying out Houdini as a Blender artist, and it seems a lot of you have interest in Houdini. So this is going to be a series where I teach Houdini like it was Blender, because I think they're quite similar in how they work, just that Houdini is a lot more powerful and used way more in the professional world, especially in commercials and VFX heavy movies. So this is what we're going to do with Houdini. We're going to create a rolling carpet like this, and then export it into Blender and just render it out like this. Doing something like this in Blender is quite difficult. As you can see, these are actually cloth simulations rolling, basically carpets rolling out just like that. It's really tricky to do in Blender. I don't even think it's something that is possible to do without using add-ons. But if you know how to do it, you can try it out and let me know in the comments if you are able to do it using Blender. It's difficult to control cloth simulations like this in Blender. Anyway, let's jump into Houdini and take a look at what we're going to be doing. Yeah, what I discovered is that Houdini is much easier to learn if you know some bit of geometry nodes. So if you are interested in learning geometry nodes, I have a course about that. Links are going to be in description. That way you can improve your Blender skills and also make your Houdini journey easier as well. By the way, you can get the Houdini project files and the Blender project file of this project in the description. Let's jump in. I'm not going to teach every button like a Houdini beginner tutorial. I'm just going to explain the steps that are necessary to do something like this so that we don't make this a very long tutorial. Let's first go through the basic interface as that might be required for doing this. So the arrangement of the windows is a bit different from Blender, but it's intuitive and easy to understand. We have our 3D viewport. You have your node editor, similar to what Blender would have, like the geometry nodes editor, and you have your properties or settings. In Blender, when you have an object, let's say instance on points node, all the settings are on the node itself, but in Houdini, the settings are in this panel here. Instead of having the settings on the node itself, they are up here. This setup where the settings are all on the node works fine for Blender, but for Houdini, it doesn't, because a node can have several settings and even have tabs where you can see this extrude poly has a lot of settings here. That's a lot. They can't just fit on the node itself, and it also has panels. And you can see the whole node tree that we're going to be creating to create this effect, just carpets rolling. And at first it might seem like it's really complicated, but actually is not, especially when you realize that what we're doing is we are simulating only one thing here and then duplicating it a few times. Let's see. Yeah, we're duplicating it 3 times and changing the time. So I simulated the whole carpet rolling, and Houdini has this retime node where it lets you change the timing. So here I just changed the speed to 2. I can change it to 3. So I created a cache, backed it to my computer, and then now I just duplicated it a few times and changed the speed and also moved everything. So this is sped up twice. This is sped up once. This is 1.3 and 4. And then I transform them by just moving them a few centimeters and then join them back to create 4 rows. I'm just showing you this so that you understand that this is not that complicated. And then here I'm just doing some UV mapping. All of these nodes are just for those things we have looked at. All we are left with are these. So let's talk about that. In Houdini, you have these geometry containers similar to what you would have, say if I had a cube like this, and instead of adding another cube or adding another object here, let's say I did everything in edit mode and added a plane and maybe edited it and did everything I wanted. Or similar to what geometry nodes does, if I create a geometry node setting, this now becomes a container for everything that I'm doing here. So I can even add a UV sphere and now maybe join it using the join geometry. So this has become a container itself. Let me transform it. This has become a container of the geometry, in that we can even do stuff like animate. Let me use a time scene here in the rotation. Yeah, that we can do everything inside this one single geometry object. If I want to do something else, I can even do that in another object container. So this is the same concept as using this geometry. So I have a geometry object, and that geometry contains all my carpets. So I can do the same thing, create another geometry container, just right click in this area and use the geometry, create a new geometry. We can call this tutorial and recreate the same thing inside this geometry container. Let's talk more about the 3D view. If you want to navigate it, you can hold on Alt and drag, left mouse drag to orbit. You can zoom in using holding down Alt, moving up and down. You can hold down your middle mouse button to pan. Like Blender, Houdini also has these panels here where the user interface changes depending on what you're creating. If you go back, you can see we are in the build, but there is also the animate that will change the interface to add panels that you normally use with the animate, but we're going to go to the build. So if you lose any of these panels, you can just click the plus and just look in these views. So there is a scene view, compositor, inspector, like the spreadsheet we have in geometry nodes. Yeah, so if you lose anything, you can just add it there. You can also reload the current desktop in case everything gets messed up. Okay, let's go inside the tutorial geometry container and start working on this. You can see as I'm going into this, we are seeing some ghosting the previous geometry. If you don't want that, when you are inside the geometry container, you can go up here and show all objects or hide others, and that will hide the other geometries. To create our carpet rolling, we are going to start with a line. So just search for line, and we want this to run on the X and Y. So Houdini uses Y as the up axis instead of Z like Blender. So let's start with the line, and we want it to run in the X. So just zero out the Y for the direction, and you can resample the curve using a resample node, and let's take a look at that. Now I want to see the points we are adding. So this panel here gives you different ways to display your data. I want to visualize the points, so I can click on this dot here, and that will show me the points of vertices in my curve. I can reduce the distance between these points by reducing the length, and that will give me more points. Now I want to extrude this into a carpet, so I'm going to just drag from this point and tap to edit mode and search for poly extrude. These nodes have different segments, and each segment does something different. The first node just previews that node. It is similar to what you would do in Blender. We have several geometries, but if you want to preview just, let's say, the UV sphere, we connect this to the viewer, and that will show us that node. If we wanted to preview this, we preview that. So that's what this is. So instead of having a previewer node, each node has that icon to display that node. We want to extrude this vertex, this edge. So like in Blender, whenever you want to extrude something, so let's first go to, let's add a grid, preview that. Now, if you want to extrude this, you use the extrude node, extrude mesh, and you have to select the type of data you want to extrude. So there is vertices, there is edges, and there is faces. Now in Houdini, you also have the same option. If this was, say, a grid, let me just add a grid, and again I want to preview the grid, so I'll turn that on, and let me remove some of these rows. So if I just use an extrude poly extrude on this, I can just increase the distance, and you can see that I extrude this already. So this extrudes the polygons on the face. So if I had several, yeah, it would extrude them as well. It also has the same settings as Blender, so I can even extrude in video elements and maybe increase the insert. And this is the similar behavior to what you have with Blender. So if we had more subdivisions here, we can get the same behavior from this node. But let me go back to the wire. But if you want to extrude a line like this that doesn't have faces, you have to turn on extrude from front, and you can translate this. When you hold down your middle mouse on any value, it gives you this slider that you can use to change the values according to different segments. So just hold down your middle mouse and don't let go, and you can just change between the different steps you want to use. So if I want to move this in smaller increments, I can go to this segment here and it will be smaller, and here in larger steps, in very large steps. Now you can increase the divisions, to have something like that. I don't want to see the points anymore, so I'm just going to disable that, and we have that. Next thing is to turn this into a cloth simulation. To do that, all you have to do is add a Vellum config cloth. This is going to give you all the cloth settings you want, and the lines you see there are just the constraints necessary for cloth simulation. And after you do that, all you need is a Vellum solver. So just search for Vellum solver. Now if you preview that, if we do a bunch of calculations down here, I have to give it some time, and it's done. And always make sure that you are on frame 0 when you're doing this. I did this when I'm at frame 36, so it has simulated up to frame 36, and the cloth is falling down. You can see that this is working, the cloth is falling. And if you select the solver, you can see the solver settings. And the first thing I want to do is turn on collisions. Now I can also just go back here in our simulation, make sure you're at frame 1, so that the solver doesn't try to simulate. I can add a transform node here, and to add a node between different nodes, you can just pull on it and press tab and search for the node you want to add. So I want to add a transform. Let me preview that. I'm going to move this up and maybe rotate it slightly, just like that. And I can now go back to the solver and hit play, and you can see we have a cloth. That was just to verify that we have a cloth. I added the transform just to show you that this was a cloth simulation. So I can disable that using Q. Just select the node and hit Q, and that will disable it. We want to do the carpet roll effect. If you're creating a simulation like a cloth simulation, whatever you add between this Vellum constraint and the Vellum solver can be used to direct your simulation. For example, I can add a transform node. Let's take a look at just that. We already saw that the transform node can be used to move things, but it can also be used to move just vertices. So for example, Blender has vertex groups. So let's say Shift A, if I create a few subdivisions here and select, let's say these, go to vertex group, create a new vertex group and assign it. So I've created a new vertex group. In geometry nodes, I can create operations that affect only that vertex group. I can add a set position and move this up, but I only want the vertices in my group to be affected. So I can use an attribute node, a named attribute, grab the vertex group and use that as the selection. And you can see that only the vertices that I selected are moved. And if I edit those vertices and add more, you can see that those are also getting moved. So that's what we're going to do here. So I can use this to translate up, but I want to create a selection of points. Basically, create a vertex group. And to do that in Houdini is very easy. Nearly all nodes you have this group selection input. So you can see the Vellum has it here. The poly extrude has it up here. It's normally the first input. And that's basically to select vertices or faces you want to move. So I can click on this icon here and it will take me into the selection mode. I want to select vertices. So up here, I can change my selection to points and just select a bunch of points. And when I'm done, I can press enter. Now, Houdini also gives you some hints you can use down here. So you might want to watch out for those. So I'm going to hit enter and you can see now I've moved just those vertices. I can actually keyframe this, so we can start from 0. Let's go to the first frame, hold down Alt and click on the input you want to animate. So I'll Alt and click on that. Go to frame, let's say frame 49, and just move this a few inches up, and I'll click into that, and that sets a keyframe. So we have something like that. Now, if we go to the simulation, it will just ignore all of that animation. If you want that animation to be added into the simulation, all you have to do is add another Vellum constraint, which looks similar to the cloth constraint we added before. And it actually is, because what this node is just a bunch of templates or different settings for what we have. So this Vellum cloth is basically a Vellum constraint node with the cloth template. So you can see that nearly all the settings are the same, just a few have changed. But what we want to do for this constraint, we want to pin the cloth simulation. So we can select this, and in the constraint type, we want to use the pin to target. Then you can bring this into your setup, and you can see when you move it here, it detects the connections automatically and it will connect itself. Now we can preview this, and you can see that it's creating these constraints, pinning each vertex to itself. In Blender, just imagine we do something like we do a cloth simulation, it falls, but then set up a vertex group that becomes our pin group. So if we scroll down under shape, set it as a pin group, you can see that only this part falls. But let's say we animated this. Let me turn on proportional editing, and let me create a vertex shape key, animate this, and animate this. So if I turn back the cloth simulation, then I'm basically influencing how the cloth is being simulated. Basically, that's what we're trying to do. The only pieces that will move are the pinned vertices. That will stay animated are the pinned vertices. So if we don't have any pinned vertices, the cloth simulation will take over. But if we have pinned vertices, so if we say everything is pinned, and go back to the cloth simulation and make sure that we have a pin group, you can see that the entire cloth simulation will be disabled. But if we have just a few vertices pinned, let me go back to the vertex group, remove everything, and just keep these pinned. Yeah, you can see that the cloth simulation will work, but respecting the animation we have created. So this is what we are doing here. Every vertex is pinned. So if we go to the Vellum solver, playback, because everything is considered pinned with this pin to target, nothing, and the cloth simulation is basically not working. It's similar to when we have all the vertices pinned here. The simulation won't work. Only the vertex group animation will work. If say we selected, so we are on our constraints node, if say we pinned just these vertices here, and by the way, we can, instead of just selecting these randomly, we can create a vertex group here by just using a group node, and let's call this pin, and it should be points that we are selecting. I can enter that group. So this group node has several settings that help you select the points you want to pin. There is keep boundaries, keep normals, include edges. We can look at all of that in the future, but let's just use the best group. And when you click on this, you enter selection mode, and we can select the points we want to pin, and hit enter. So now these points are part of the pin group, and you can see that their indices have been added to that group. Now I can come in here and use only that vertex group. So I can go in the group and look for the pin group we have just created. Now, because we created this pin group under the points, we have to change from primitive to points, and now we should be able to find that there. So now you can see what we have. If you go to the solver, playback, you can see that the cloth is working. Now, because I have the ground on enabled, I'm not seeing anything. So I'm going to just disable it for now. You can see now things are falling, but that part stays, which is perfect. Now, remember, we created this animation where we have this going on. So to keep that animation with the simulation, we have to go to the constraints settings, and let's take a look at that and turn on match animation. Now, if we simulate again, go back to the simulation, you can see that this is working as well. Another thing we could do under transform, instead of using some random points, we can still use our pin vertices. Also, let's remove the other vertices and just use our pin collection. Playback, and you can see that now when this is moved, the whole cloth is moving. That's the setup we want to use. But instead of using the transform node, I'm just going to delete, and use a different node called the bend node. That is going to give us that roll animation. So I'm going to tab and use the bend node, which works like the bend modifier, but more advanced. So I'm just going to look at that and try to bend this the way I want. Each node has gizmos like what we have in Blender. You can click on this, I think it's called show handle node, and it will show you the handles for any modifier that you're using, if that modifier has handles. Now the bend modifier has several handles that you can use to bend your objects, and I'm just going to bend this a few times like this, but the angle is off. So I'm going to go to this and look at the direction, change that. So just perfect. Can rotate this a few times, and you can change the angle length and the capture origin. So you can see that this is going to be our rolling setting, but we wanted to make a lot of rolls before. So I'm also going to add some direction in the roll here. So you want it to turn around like this. Let's increase the number of rolls. You don't want it to intersect because we're going to create a cloth simulation, and the intersections like this can cause issues. Actually, let's animate this from 0. I'll set a keyframe there to 120, and from 0 to 1. So this is 1. So if I take a look at this, you see how it's rolling, but I don't want it to intersect. So I have to find values that work until you get something that works for you. So you want to have a roll animation like this. If you go to the simulation, this is what we're getting. Because we want to maintain the rolling of the carpet, in the Vellum constraints, instead of just selecting pins, we can select everything. And if you have nothing in the group input, it will just select all the nodes, and that's what we want. So if I play back the simulation, you can see the simulation, you can see that everything, the carpet is rolling, but because everything is pinned, we don't get any cloth simulation. So what we're going to do in the group node, instead of selecting just a few points, let's look at different selections. The first one I like is this include by edge. So I will enable that and make sure that I'm previewing this. So it has these unshared edges, which will let us select all the boundary edges, and we can use that as our pin group. And in our constraints, let's use the pin group again, which will pin the boundary edges, making them follow the animation, but the inside vertices won't. So I can go back here, take a look at my solver, and just now you can see that the inside gives us that simulation, but the outside doesn't. Now I'm also going to go back to the cloth constraint, which is the settings for our cloth. And there are a ton of settings here that I'm not going to explain a lot, but the one thing I want to do is change the stiffness and rest length. So rest length is just how stretchy the cloth is going to be. So if I increase this a bit, I should be able to get more wrinkles. And I think I need to add, I can go back to the solver and bring back the ground. And you can see we have something like that. And let's see what else do I need. So having a pin selection like this, where we're selecting the boundaries, is good, but it's not giving us the best effect. So let's find something else. So I'll disable all of that, and let's select keep by chance. And this will just give us pin random points, and let's use only 10%. So instead of pinning the boundaries, we are going to pin just randomly. I want to include some of these here. Let me change the seed. Now let's go back to the simulation. And let me go back to the cloth and bring back the rest position to 1. Now I can simulate. And we have a carpet roll. That looks better. Now, when you're done with that, you can add a Vellum post-process. This just improves your simulation, and you can also add thickness to your cloth. So you can see that the cloth has thickness. Our carpet has thickness to it, and yeah, it opens up. You can even add more subdivisions. Let's do that up here by using our remesh node. And we need to reset our simulation. Go to the remesh and reduce the target size just like that. And I can look at the post process. Because it's after the Vellum solver, it will also activate the solver. So if I just play back, yeah, we get our carpet rolling. The other thing I did was cache. Do a file cache for this so I can save to disk, so that I don't have to resimulate every time. And you can see how easy this is if you know the nodes you want to use, if you know what you want and the nodes to do it. Houdini is quite simple. Now that we have our cache, I can now use the transform node to create 3 copies moved here. And I actually can even bring a merge node. Take a look at that. So this is our transform. This is the original. And I can Shift D to duplicate this, add this in, and also move it just a bit. Alt D, move this just a bit. So we have the same animation. And we can use a retime node, to change the speed or starting position. So I can just duplicate this. So when I play back, I get this opening up. So now the rest is just setting up UVs. And to do that, we can do a quick UV, a UV quick shade. And that will show us how our UVs look. But you can see that the UVs are stretching, which actually may not be that bad. Another thing I'm seeing is that this is not folding all the way, and that's because our input frame range is 100 and our simulation is 240. So make sure that this is set to 340. Now, if you want to export this, all you have to do is go under File, Export Alembic, and select Export Frame Range, and then Export. Then you'll be able to bring it into Blender and do whatever you want. So yeah, project files are going to be available on my Patreon page and my YouTube membership page if you are interested in this. Links are going to be in the description.